All right, class. Today we are going to talk about something really fun that you have already experienced in your daily life without knowing the science behind it. Imagine you are blowing air into your soup to make it cool faster. Or you feel warm air from a heater during winter. Or you see water being cooled inside a car's radiator. All these things are done by a special machine called a heat exchanger. Now, a heat exchanger is simply a machine that lets heat move from something hot to something cold without the two mixing together. It's like having two friends passing a toy across a wall without seeing each other. The wall is there, but the energy moves through it. Heat exchangers help us do many useful things, like warming our rooms, cooling our drinks, running power plants, and even helping cars run better. There are many kinds of heat exchangers, just like there are many types of ice cream. The simplest one is called the double pipe heat exchanger, where we have two pipes, one inside the other, like a straw inside a tube. One fluid, like hot water, flows in the inside pipe, and the cold water flows in the gap between the pipes. They can move in the same direction, like walking side by side, or in opposite directions, like a race. When they move opposite, it's called counterflow, and it cools things better. Then we have compact heat exchangers, which are like super tiny pipes packed closely, just like honeycombs in a beehive. They are used when we have very little space but still need to transfer a lot of heat, like in cars or airplanes. Some have straight pipes, others have zigzag or even funny-shaped channels to make the fluid swirl around more so it heats or cools faster. Another type is the shell and tube heat exchanger. Imagine you have a bunch of small straws inside a big bottle. The hot water goes inside the straws, and the cold water goes around the straws inside the bottle. Engineers like this one because it can handle a lot of fluids at once, and it's easy to fix by taking off the covers. Then we have plate heat exchangers. Instead of pipes, these use lots of thin plates stacked like a deck of cards, with fluids moving in between. This is great for saving space and making sure the fluids heat or cool each other really quickly. These are like your multi-layer sandwiches, where each layer has its own filling. Some heat exchangers store heat and give it back later, like rechargeable batteries. These are called regenerative heat exchangers. They work by heating up a solid block or rotating drum with hot fluid, and later cooling it down by giving the heat to the cold fluid. One important thing in heat exchangers is fouling. This happens when dirt or solid stuff sticks to the pipes inside, like when your teapot gets a layer of minerals after many uses. When this happens, it becomes harder for heat to move through, just like when dust clogs a fan. Engineers calculate how much dirt builds up and design the heat exchanger big enough so it still works even after getting dirty. Engineers use something called the overall heat transfer coefficient to describe how good a heat exchanger is at moving heat. A high number means it's really good at transferring heat, and a low number means it's not so good. They also check how easy it is for heat to pass through the wall between the fluids, how dirty it gets, and how fast the fluids are moving. This helps them decide if they need bigger pipes, more plates, or extra fins to make it work better. Finally, when we want to figure out how much heat is transferred, we use something called the log mean temperature difference, which is like taking an average temperature difference, but in a smarter way since the temperature is always changing along the pipe. Engineers use different formulas for different situations. Sometimes both ends of the pipe are changing temperatures, sometimes one end stays the same, like in boilers or condensers. So next time you see a car radiator or feel your room heater, remember there's a smart design inside that makes sure heat moves from hot to cold efficiently, using these amazing tricks of nature and engineering. And that, my friends, is how we use heat exchangers to make our life comfortable and our machines work better.